Hello viewers, welcome again to today's lesson. This is the solution space, the platform where mathematics is made easy and simple for everyone to understand and to enjoy. In this video, I want to teach you a new topic, and that is logarithm. As you can see from the board, I've written logarithm on the board. So that's what I want to teach you in this video. Logarithm is one of the topics in mathematics which most students struggle a lot with it. But actually, logarithm can be very easy and simple if you get the basics right. So it's just about you getting a good foundation to the topic, and you are going to realize that logarithm is actually one of the easiest topics in mathematics, and you are going to enjoy it very much. So in this video, I'm going to take my time and lay a very good foundation to the topic. We are not going to rush it. I'm going to start from the scratch and we are going to build it step by step. Okay, so please do well to follow all the videos that I'm going to make on this topic, logarithm. Don't skip any of it so that you can get a perfect understanding of it. Okay, now I'm going to start with introduction to logarithm, okay, so that you can appreciate the topic and get a perfect understanding of it. Okay, so in this session, we are going to tackle introduction to logarithm, as I've written on the board, introduction to logarithm. Okay, and you can see that I've written the definition of logarithm on the board. But before I go ahead and start to explain the definition, there is something very important that you are supposed to take note of. Now, the knowledge of logarithm is built on indices. One more time, I'm saying that the knowledge of logarithm is built on indices. So if you don't have any idea of indices, then you are likely going to struggle with the topic. And I've already taught you indices in the previous videos. Okay, we handled indices as a full topic. We started with introduction and we looked at all the various aspects of indices, and we've also solved a lot of examples on it as well, all in the previous videos. So do well to search for those videos that I've done on indices in case you don't have any idea of what indices is, okay, so that you can watch them and get a good foundation to be able to handle this topic as well. Because as I said, we are going to apply the knowledge of indices here in logarithm. Okay, so just search for the videos that I've done on indices on Facebook or YouTube, okay, and you'll get access to all the videos. It's a complete video, step-by-step teaching and explanation of indices. You will understand it perfectly so that you can easily handle this topic as well. And please don't forget to like the videos and also share them after watching. And if you are watching for the first time, please do well to follow my page and also subscribe to my YouTube channel as well. Now, let's go ahead and start with the introduction to logarithm. Okay, now, before I say anything about the definition that I have on the board, you have to take note that the knowledge of index of numbers is very important. That we've done it in indices. I've taught you indices and we looked at how to write numbers in index form. Okay, so writing of numbers in index form, that knowledge is applicable here. Okay, that's why I keep on encouraging you to go back and watch the videos that I've done on indices. Okay, now, what does it mean to express a given number in index form or in exponential form? Now, to express any given number in index form or exponential form simply means that you are going to write that number as a repeated multiple of another number. Very simple as that. I'm going to repeat it one more time. To express any given number in index form or in an exponential form simply means that you are going to write that number as a repeated multiple of another number, okay, which will result into that same value. Let me use some examples to explain it to you. Okay, so assuming I have 4, okay, and you are being asked to express 4 in index form. Expressing 4 in index form simply means that you are going to pick one number that will multiply itself several times to give you the 4. So that's the meaning of you expressing 4 as a repeated multiple of another number. So we are going to pick one other number that will multiply itself several times to give you the 4. I hope the explanation is clear enough up to this point. Okay, so now the number that comes in mind is 2. Okay, because when we multiply 2 by itself again, which is 2 times 2, it results in 4. Okay, so that is the repeated multiple. Are you okay? So 2 is multiplying itself 2 times to give you the 4, which I'll write it in exponent form as 2 to the power 2. I hope you understand up to this point. All this I've done a detailed explanation on it in the previous video, which is the indices. Okay, now let me pick another number also. Let's say I have 8 and you are being asked to express the 8 in index form. Simply means that we are going to pick one number that will multiply itself several times. Okay, so that same number will multiply itself several times to give you the 8. And what number comes in mind? It's obviously 2. Okay, so I'm going to have 2 times 2 times 2. Okay, let's check it and see. 2 times 2 is 4. 4 times 2 is 8. Okay, so it means that my 8 in index form is going to be 2 to the power 3. If you are wondering why it is 2 to the power 3, it's very simple. What number are we using? We are using 2. How many times do we have to multiply the 2 by itself to give us the 8? It's 3 times. So that's the 2 we are using, which is here. And we needed to multiply the 2 3 times, okay, by itself to get the 8. That's why we have the power 3 here. So 2 to the power 3. I hope the explanation is clear enough up to this point. One more example. Let's say I have 9. Okay, and I'm to express 9 in index form. Don't forget, it simply means that we are looking for another number that will multiply itself several times to give the 9, and that will be 3. I hope you agree with me, because when we do 3 times 3, it results in 9. So 9 in index form is going to be 3 to the power 2. I hope you understand. The very last one, let's say I have 16. Okay, so now to express 16 in index form, ask yourself which number will multiply itself several times to give you the 16, and that is 2. So we know that we have 2 times 2 times 2 times another 2. Let's check and see. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So it means that 2 to the power 4 gives 16. So 16 in index form is 2 to the power 4. I hope the explanation is clear enough up to this point. Now, someone may be wondering, why not 4 instead of using the 2? Now, if you use 4, there is nothing wrong with it. So someone can choose that I have 16 equals to 4 times 4. Okay, 4 times 4 gives 16. So we'll write it as 4 to the power 2. There's nothing wrong with it when you do this. Okay, the only difference is that this is the simplified form of what you've written here. Are you okay with this? So depending on the question, that will inform you whether you are supposed to use the simplified form or not. Are you okay with it? As you proceed, you will get a better understanding of it. So the question will demand or will inform you whether you are supposed to leave the value in the simplified form as this or as this, and you will decide on that based on the question that you have. Okay, now let me show you that this is actually the simplified form of this. Okay, 4 to the power 2 is the same as 2 to the power 4. How did we know that? Now, when you have 4 to the power 2, now let's break the 4 down. Breaking the 4 down, we can break the 4 down as 2 times 2. I hope you agree with me. So this 4, I can write it as 2 times 2 in a bracket like this, and don't forget to bring your power 2, which is here. Are you okay with it? Now, this power 2 affects the 2 here and also affects the 2 here. So it's going to be 2 to the power 2 times 2 to the power 2. I hope you understand. The power 2 affects this and also affects this as well. Now, 2 to the power 2 means what? 2 times 2. And this 2 to the power 2 also means what? 2 times 2. So it becomes 2 multiplying itself 4 times, which results in the same 16 as we've done here. Look at it, 2 to the power 2, you break it down, it means 2 times 2. So 2 times 2. And this 2 to the power 2 also means 2 times 2. So it results in the same thing. So this is just the simplified form of this. Okay, and I'm saying that the nature of the question will inform you, will give you an idea whether to write the simplified form of it or not. Okay, so you don't need to worry about that. All that you need to do is to understand how to write any given number in index form. I hope the explanation is clear enough up to this point. Now let me clean the board and let me take one example or so and use it to derive the understanding of the logarithm. Okay, let's say I have 32 on the board, okay, and I'm asking you to write the 32 in index form. By now, I know that all of you can attempt it or can do it, okay. So which number will multiply itself several times to give the 32? And that will be 2. I hope you agree with me, because I'm going to have 2 times 2 times 2 times 2 times another 2. 2 will multiply itself 5 times to give the 32. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So my 32 will be 2 to the power 5. I hope you understand. So having the 32 in index form is 2 to the power 5. I hope the explanation is clear enough up to this point. Using the knowledge of what we've learned so far, I'm going to explain the definition of logarithm to you. Okay, so let's look at the definition on the board. It says the logarithm of any number into bracket b. So b just represents any number you can think of. In my case, I'm using 32, but you can think of any other number. Okay, so it says the logarithm of any number into bracket b to the base a. What is the base? The base simply refers to the number that we expressed the 32 in. Okay, so now I use 32 and I expressed it as 2 to the power 5, which is the index form. Okay, so the 2 is the base and the 5 is the exponent or the index. So the base here is referring to the number that you used, okay, in expressing a given number in index form. I hope you understand. So in my case, my base is what? The 2 that I have here. Okay, now it says the logarithm of any number into brackets b to the base into brackets a, written log b to the base a. So log b to the base a. Let me write that for you to see. So log, my b refers to the 32, okay, so that's the 32 to the base a, so which refers to the 2, so to the base 2. So log 32 to the base 2 is means equal sign. So let me read it one more time. The logarithm of any number to the base which is written as the log of b to the base a, is the index to which the base must be raised to give the number. So now, all that this is saying is that I'm using 32, and the 32 I've expressed it in the index form, which is 2 to the power 5. The definition is saying that when I take the log of 32, okay, now maybe someone is wondering where from the log. The log is simply coming from the logarithm. Okay, it's just like we talking about cosine, tangent. When you are writing cosine and when you are solving with it, you know that you don't spell the whole cosine. You write the cos, okay, which represents cos, okay, which is the same as cosine. And when you are writing the sine, you don't write the full sine, you write sin, which represents the sine. When you are writing the tangent, you don't write the full tangent, you write tan. So you use the first three initials, okay, so it's the same thing. So the first three initials, that's what we call log. Instead of writing it in full, you write the first three initials. So the log of 32 to the base 2, okay, should be equal to 5. Okay, now, so the logarithm is just the inverse of the indices that we know. So look at something, the 32, I've written it in index form as what? 2 to the power 5. And the definition of logarithm is saying that when I take the log of the 32 to the base, and the base I've explained it to you, it means that that number that you used in expressing the 32 in. So my base here is the 2. So the log of 2, the log of 32 to the base 2 should be equal to what? The power, okay, which is the 5. Okay, so that is the meaning of the definition that I have on the board. Now let me use other example. Let's say I have 16. 16 in index form is 2 to the power 4. I hope you agree with me. So the log is just saying that when I pick the log of 16 to the base 2, it should be equal to the power 4 that I have here. So it is the opposite of the indices that we know. I hope you understand up to this point. Let me use other examples to explain it to you. So let me clean this one from here and let's proceed. Let me say I have 9. So 9 will be equal to 3 to the power 2. Is that also? So now, the 3 to the power 2, the logarithm is saying that when I pick the log of 9 to the base 3, it should be equal to 2. Okay, so that is the logarithm law. I hope the explanation is clear enough up to this point. So we are going to use this understanding to derive other stuffs about logarithm in the next video. Okay, now let's do one more before I end this session. Okay, so now let's say I have 81. Okay, let's say I have 81. 81 in index form is going to hold 3 to the power 4. Okay, so now the logarithm law or the logarithm definition is saying that when I take the log of 81, which is this, to the base 3, so to the base 3, it should be equal to the power 4 that I have here. Okay, so that is the definition for logarithm. I hope the explanation is clear enough up to this point. So it means that in general, when I have the log of b to the base a, it should be equal to c. Are you okay with it? So this is the definition of logarithm. I hope the explanation was clear enough and you understood it and you enjoyed the lesson as well. So in the next video, we are going to continue and look at other aspects of the logarithm. Thank you, and don't forget to like the video and also share as well. And if you are watching for the first time, please don't forget to follow the page and also subscribe to my YouTube channel as well. Bye bye.